Hello everyone, welcome back to the channel. In today's lecture, we are going to explore an important topic in microcontroller. Lecture 2, Architecture of 8-bit microcontroller. In this section, we will focus on the internal working and structure of the 8051 microcontroller, which is one of the most widely used 8-bit microcontroller in embedded systems. We will cover three key concepts today. First, the architecture of an 8-bit microcontroller. How different components like CPU, memory, and input-output ports are connected internally. Second, the feature of the 8051 microcontroller, including its memory organization, timers, serial communication, and ports. And finally, we will understand the program status word PSW, a very important register that keeps track of the processor's current state during execution. By the end of this lecture, you will have a clear understanding of how an 8-bit microcontroller works internally and how it manages operations efficiently. So let's get started. Recap on the basics of microcontroller. We have studied in the previous lecture. First of all, we have seen the microprocessor and microcontroller definitions. Second of microcontroller evolution, microcontroller types, real-time applications. These things we have studied in the previous lecture in details. Now we come on today's lecture. Learning outcomes. After the completion of today's lecture, we will learn about these. First of all, 8051 architecture and components. Describe the core architecture, memory organization, input-output ports, and CPU functionalities within the 8051 microcontroller. In terms of program versus data memory, analyze the distinct characteristics and usage patterns of program memory and data memory in the 8051 microcontroller. Data flow in execution. Explain how data is transferred and processed within the 8051 during instruction execution cycle. After completion of this lecture, we will learn about this. Okay? Okay, now we can move for today's lecture. First of all, you can see here, right? 8051 architecture. This is just IC of the controller. Important features of 8051 microcontroller, right? That is the first important feature is 8-bit microcontroller, right? Second feature is 16 16 address lines. Okay. For this addressing line, we will use for this data transfer with the help of the memories. So 64 KB external code memory, right? These are the important features. 64 KB external data memory, right? Code memory, data memory, right? Next thing, operating voltage. For this IC, the voltage is required for 5 volt DC supply, right? Clock frequency, that is 1 megahertz to 40 megahertz, but generally we will use the frequency 11.0592 megahertz, that is the crystal frequency, right? Crystal oscillator frequency that will use in the 8051 microcontroller. Okay. Now 4K byte ROM, that is the program memory, right? This is the program memory. Program memory is nothing but code memory. We have used this term also here, you see the code memory. Code memory is nothing but program memory. That is also called the ROM, read only memory. Understood? Now 128 byte RAM data memory, right? This one data memory is nothing but RAM, read random access memory, right? This is the full form of RAM. Next thing, this is also the important part of this microcontroller. 4 8-bit input output ports, that is all pins just like 32 input output lines are available in the 8051 microcontroller, right? 216-bit timers also available in 8051 microcontroller, right? Serial interface for the communication purpose, for the data transfer one device to another device, right? So we can use this serial interface. Okay. Next thing, 6 interrupt sources also available in this 8051 microcontroller, right? Now we come on the what is the external memory capacity of the 8051 microcontroller, right? So you can see here the 8051 supports Harvard architecture. We have seen this architecture in the previous lecture. You can, if not done by you, you can go for the first lecture. What is the meaning of this Harvard architecture? Basically, that is the architecture. The Harvard is the scientist name, right? So Harvard architecture you have just seen. If not seen, so you can go for the first lecture. You read out this and what is the Harvard architecture. This generally we will use this Harvard architecture in the microcontrollers. Hence it can support 64 KB of program memory, right? 64K, you know the K, that is the 10 ki power 2 ki power 10. Okay, this is the representation of this, right? Of program memory. Program memory is nothing but ROM. Okay, permanent memory we can say. 64 KB, 64 kilobyte, and a K that is the 2 की power 10, and B that is the byte of data memory. This is for the temporary purpose, RAM, right? Now we come on the 8051 architecture. This is the very important, right, architecture for the 8051. Internal architecture basically. So you can see here in terms of just you see here we can start from here the ALU, right? ALU, that is the arithmetic logic unit, right? This is basically the register. Okay, so this register is a 8-bit register, right? So we can, you see here, these are the register also use. A, that is also register. This is also 8-bit register. B, that is the register. This is also the 8-bit register. Remember, right? Some more registers also used in this 8051 microcontroller. DPTR, that is the data pointer. Generally, we will use this DPTR as a addressing. Okay. This register is the 16-bit register, right? PC, that is the program counter. It is also the register, that is the 16-bit register. Okay, we come here, this line represent the 16-bit address bus. You see here, these are the lines. This lines is nothing but buses. This is called the bus. Okay, data bus and the address bus. So we can use here this term. Okay. Now another register is available here, the PSW, program status word. Okay, that is also called the 8-bit register. Understood? Okay. Now we come here. This is the ROM, right? ROM, read only memory. This memory space is 4K byte. Okay. Now you see here, this is the special function register and RAM, right? This is the 128 byte. Okay, this RAM. Now you come here in this, these are the latches. Okay, we can connect these things with these ports. Okay, so 4 ports available in the 8051 microcontroller, right? So we can use as an input or output as per the demand we can use, right? So first of thing you remember, the this port will connect as with the help of the latch. Okay, latch, this one, port 0, port 1, port 2, port 3. Each port has the 8 input output lines. Okay, port 1 also the 8 input output lines. Port 2 also the 8 input output lines. Right. Port 3 also the 8 input output lines. Right. Next thing we can use as a port 1. One most important thing. These ports, port number 1, 2 and 3. These ports are connected pull-up register internally, but in the port 0, if we are using as a right input output, then pull-up register should be connected externally. Understood? Okay. One more thing, we can use the port 0 also for the addressing and data purposes. AD not to AD7, right? A represent the address, D represent the data. We can use port 0 as the address as well as data. Depends on the requirement we can use, right? One most important thing also you see, port 2 also used for the input output lines, but this is also used for the addressing purpose. Remember, for the addressing purpose 16 lines is required. So how to maintain these things? So we can maintain from here 8 addressing line from here, from port 0, 8 address line from here, A8 to A15, that is from port 2, remember, right? Port 3, that has the number of benefits for the users. Basically you see here 8 input output lines you can use as an input or as a output, right? Second thing, you can use as an interrupt purpose, right? We will see what is the interrupt and what is the role of interrupt in this 8051 microcontroller, right? Counter also facilities available here for purpose of the delay or purpose for the counting purpose, counter, right? Next thing also, there serial communication in this port also provide this facility. Serial communication, if we want to transfer data from one device to another device by using this port. Okay, remember. And for the read or write purpose also provide this facility, read or write. And read data from the memory, write data for the memory. Okay. So these are the things we can move for the expanded of this port 3 you see here. And this is the thing also available. And EA, right? EA, that is the external access, right? You see here. ALE, addressing latch available, right? PSEN, that is the program store enable. These are the things connected with the 80 microcontroller port 3. But we will see what is the basically use of this, how to use this one, right? And also crystal oscillators we will connect here, XTAL1, XTAL2, right? With the help of these pins we will connect this crystal oscillator, or any oscillator we can connect here. Generally we will use here the crystal oscillator. They provide the stable pulses to the microcontroller, right? VCC, that is the requirement of this, and ground, right? These are the things we will connect with the microcontroller, or we can use accordingly, right? Internal RAM structure and SFR, right? We can see here this is the organization of the RAM, right? General purpose. Okay, we can start from the below to up, right? So first of all, the bank 0. This is also the 8 registers are contained here, right? Bank 1, bank 2, bank 3. So basically 4 banks are available, right, in the RAM. And another space for the bit or byte addressable thing, and also some space for the journal purpose, right? So we can organize as per the need, as per the our application, right? And also some special function registers are available in the 8051 microcontroller. TH1, TL1, right? TH0, TL0, TMOD, TCON, SCON, S buff, PCON, IP, right? IE. These are the special function register. We will use the one by one what is the benefit of these special function registers in 8051 microcontroller. Now we will see the summary of this 8051 architecture. The internal architecture of the 8051 microcontroller. At the heart of the microcontroller, we have the arithmetic logic unit or ALU, right? Which performs all arithmetic and logical operations. It works closely with two important registers, the accumulator A and register B, right? Just above that, we have the program status word, which keeps track of important flags like carry flag, overflow flag, and register bank selection. We will see also in the next slide in the detail of this program status word register, right? Look at these registers, the program counter PC and data pointer register DPTR. These are 16-bit registers used for addressing memory location. We have already discussed. Now moving the memory, the 8051 contains 128 bytes of the internal RAM and 4K byte of ROM, right? Internal ROM, right? The RAM is used for temporary data storage, while the ROM stores the program instructions. Here you can also see the special function registers. These registers control various operations like timers, serial communications, and interrupts. On the right hand side, we have four input output ports, port 0, port 1, port 2, and port 3, each having 8 input output lines. These ports allow the microcontroller to interact with external devices. Okay. Notice that port 0 and port 2 are also used for addressing and data buses, which helps in external memory interfacing. Understood? At the bottom, we have the system control block, which includes timing circuits, interrupts, timers, and memory control signals. Finally, signals like EA, ALE, PSEN, RD, and WR are used for controlling external memory and communication. Remember. So, this entire architecture shows how different components of the 8051 microcontroller are interconnected to perform efficient operation. Done? Now, we will see the program status word PSW or flag registers, right? We will see in the detail of this program status word, right? So first of all, this program status word, that is the 8-bit register. Okay, so we can represent in this way PSW.0, PSW.1, PSW.2, PSW.3, PSW.4, PSW.5, PSW.6, PSW.7. Okay, so this is basically the bit addressable thing you see here. This is the parity bit. Okay, parity bit is fixed here in the PSW.0, right? Another, that is the dash. This represents the user defined bits. Generally this bit and that bit, right? F0. This will not be used in this. PSW.2, that is the overflow flag, right? PSW.3, that is the RS0. PSW.4, that is the RS1. This is basically we can select the register bank by using these bits. Okay. Now we can come here. We have seen already the F0. This is only for the user purposes. User defined bit basically. And this one PSW.5 or PSW.1. Remember, right? PSW.6, that is the AC. AC is nothing but auxiliary carry. Right? We will see how to define this bit, how to set or reset, how to just effect, right, of these bits. PSW.7, that is the carry flag. Okay. So this is the flag register basically. We can decide which one is the set or which one is the reset, right? First of all, we can see here the status flags, right? Carry flag, auxiliary carry flag, right? Auxiliary, OB, overflow flag, and parity flag, right? Control flags are F0, GF0, G1, right? But generally not using here. We will discuss in the future lectures what is the role of this control flags more, right? We can decide here. This is the register selection, right? Register selection bits, right? We can decide which bank registers is used here. Register bank selection bits, these are, right? So we can decide, suppose we can put here the 00. That means we want to select the bank 0, right? Suppose we can put here the 01, right? Here 0, here 1. That is the bank 1, right? Next thing, for the bank 2, we can put here 1 and 0, right? These are the bits we can put in this flag register. Next thing, the bank 3, that is the, here we can put the 1 1, right? That means we want to use the bank register, just a bank of this 1 1. This is basically related to the RAM space, right? Now we come on the summary part of today's lecture. First of all, we can already seen this thing, discuss the internal structure of the 8051 microcontroller, right? We have seen in the detail. Second thing, covered key components, CPU, that is the central processing unit, RAM, random access memory, and ROM, read-only memory. This is purpose for data and program memory, right? Next thing, already we have discussed input output ports, right? Timers, serial interface, and interrupts, right? We have seen in the internal architecture of 8051, but in the detail we will see in the future lectures. Remember, in the next class we will discuss about the spin diagram of the 8051 microcontroller, where you will learn about each pin's function, configuration, and role in the interfacing with external devices. Remember, this is the important part of the 8051 microcontroller. Basically, how to use the IC in the hardware setup. So we can learn about this in the future lecture, the next lecture. Understood? Okay. Sample questions already given here. You can see the sample question of this lecture, right? Analyze the working of the 8051 CPU with any arithmetic operation. Discuss control flags with a numerical example. Describe the function of PC and DPTR. Differentiate RAM and ROM. Right? Next thing, the controller may be small, but in the hands of a thinker, it powers big ideas. Thank you very much for listening my video.